Year 13 short revision video number 24. So we have a mechanics question. A toy boat of mass 1.5 kilograms is pushed across a pond starting from rest for 2.5 seconds. During this time, the boat has an acceleration of 2 meters per second squared. So, subsequently, when the only horizontal force acting on the boat is a constant resistance to motion, the boat travels 10 metres before coming to rest. Calculate the magnitude of the resistance to motion. So, let's start off by investigating the acceleration phase of the motion. So the motion of the boat is split into two parts. So let's look at this first part here where it's being pushed across the pond and it's accelerating. Now, we don't know this value of the velocity, so we're going to look at u, v, a and t to investigate what we can find out there. So using v equals u plus at, we can work out that v is equal to 5 meters per second. So that's the final speed at the point at which then the boat decelerates down to rest in the second phase of the motion. So let's now think about this second phase of the motion. The boat travels 10 metres before coming to rest. So in the second phase of the motion, we know that it travels 10 metres. Its starting velocity is the same velocity it had at the end of the first phase of the motion. Its final velocity is 0. The acceleration is a new acceleration, so we don't know the value of that, and we don't know the value of the time. So the key pieces of information here involve S, U, V and A. So if we look at V squared equals U squared plus 2AS as another constant acceleration equation, 0 is equal to 25 plus 2 times A times 10. And we can rearrange this equation to give us the value of A, which is minus 1.25, which makes sense that the boat is decelerating. So, the particle is experiencing a horizontal force, which is a resistance force. We can use F equals ma to work out what this is. So the resistance force is the only force acting, and that's equal to the mass of the boat, which is 1.5 multiplied by the acceleration minus 1.25, which gives us a value of minus 1.875, but the magnitude of this force is going to be equal to 1.875 newtons.